At first, nothing looked catastrophic. The drill had simply stopped. More than 1,000 feet beneath a quiet Louisiana lake, the drilling assembly was stuck. The crew tried to understand what had happened below them. Then the platform began to move. Across the water, the lake was developing a current where no current should have existed. Deep underground, miners heard a distant roar. Water began appearing inside chambers carved from solid salt. Within hours, Lake Peigneur would be transformed beyond recognition. A drilling platform would vanish. Barges, trees, and entire sections of shoreline would be dragged toward a growing vortex. A canal would reverse direction, creating a temporary waterfall, and a shallow freshwater lake would become the deepest lake in Louisiana. All of it began with a hole little more than a foot wide. But more than 4 decades later, one question remains surprisingly difficult to answer. Why was that hole drilled into a salt mine? Before November 20th, 1980, Lake Peigneur was an unremarkable but beautiful part of southern Louisiana. It was a broad, shallow freshwater lake used for fishing and recreation. In most places, the water was only a few feet deep. Along its southeastern shore rose Jefferson Island, a wooded hill surrounded by the flat wetlands of Iberia Parish. The island was not an island in the usual sense. It was one of several hills created by enormous columns of salt pushing upward from deep beneath the Gulf Coast. These formations are known as salt domes. Salt domes can trap oil and natural gas around their edges, but the salt itself is also valuable. For decades, workers at Jefferson Island had traveled deep underground to remove it. The mine beneath the island was vast. Its rooms and passageways extended through the salt at depths of more than 1,000 feet. Miners used the room and pillar method, cutting enormous chambers while leaving columns of salt behind to support the rock above them. But 2 industries were now operating around the same geological structure. Below, the Diamond Crystal Salt Company was mining the dome. Above, an oil exploration crew working under contract for Texaco was drilling near its edge. Each operation depended on maps, surveys, and an accurate understanding of a world hidden beneath the ground. On the morning of November 20th, the oil crew was drilling from a floating platform on Lake Peigneur. The work initially appeared routine. The drill descended through the lakebed and continued toward a target beside the salt dome. Then, at a depth of roughly 1,200 feet, the drilling assembly became stuck. The crew worked to free it, unable to see what was happening at the bottom of the borehole. What they did not know was that their drilling operation had apparently created a connection with part of the mine. At first, that connection may have been narrow, but it joined 2 things that should never have met: a lake full of fresh water and underground chambers made of salt. Fresh water does not simply flow across salt, it dissolves it. Once water found a path into the mine, the walls of that path began to disappear. A small opening became a larger one. More water entered. The faster the water flowed, the more salt it could remove, allowing still more water to follow. Far below the lake, 55 miners were at work. Water began rushing into sections of the mine, carrying mud, debris, and fragments of rock. The sound grew into a roar. This was not an ordinary leak that could be pumped away or sealed. It was an expanding connection to the lake above them. An alarm was raised, and the evacuation began. The miners had to travel through the underground workings and reach the hoisting system that could carry them to the surface. There was no time to investigate the source. No one knew how quickly the water would rise, whether passages would remain open, or whether the structure around them had already begun to fail. The evacuation was disciplined. Group after group reached the surface. All 55 miners escaped. Above them, the drilling platform was beginning to tilt. The crew abandoned the rig and moved away across the lake. Soon afterward, the tall structure folded toward the water and disappeared into a place that only hours earlier had been far too shallow to conceal it. That was when the scale of the disaster became visible. The lake was no longer behaving like a lake. Water was racing toward a widening depression. The current strengthened as the opening below enlarged and sections of the mine collapsed. The surface began to rotate, forming a violent whirlpool filled with mud and debris. 11 barges used by the drilling operation were pulled toward it. A tugboat vanished. Trees were torn from the ground. Parts of the shoreline broke apart and slid into the water. Around 65 acres of land were eventually lost, including sections of Jefferson Island and its gardens. People watching from a distance saw an apparently solid landscape being dismantled in front of them. And the most dangerous part of the process was invisible. As fresh water poured into the salt mine, it enlarged passages, weakened pillars, and destabilized the material above. The mine provided an enormous empty volume beneath the lake. As long as water could continue entering, the collapse could continue growing. Lake Peigneur was effectively draining through its own floor. Then the disaster changed direction. Under normal conditions, water flowed out of Lake Peigneur through the Delcambre Canal toward Vermilion Bay. But as the lake level fell, the direction of the canal reversed. Water from the bay began moving inland toward the emptied lake. For a time, the incoming water dropped into the newly formed crater as a waterfall estimated to be more than 150 feet high. Salt water traveled back through the canal, carrying marine life into what had previously been a freshwater environment. Below ground, the incoming water displaced enormous quantities of trapped air. Pressure forced air, water, and debris upward through mine openings, producing violent eruptions at the surface. The landscape had become a connected system: lake, mine, canal, and bay. Alter one part, and every other part responded. And yet, in the middle of this extraordinary chain reaction, no human life was lost. The drilling crew escaped. Every miner reached the surface. People on the lake managed to reach safety. Their survival came from quick decisions, an orderly evacuation, and an extraordinary amount of luck. Had the underground alarm been delayed or the escape route failed, Lake Peigneur might be remembered as one of the deadliest industrial disasters in American history. When the movement finally slowed, the old lake was gone. But Lake Peigneur did not remain empty. Water continued flowing backward from Vermilion Bay until the basin filled again. What returned was not the same lake. The former shallow freshwater lake now contained a crater reaching roughly 200 feet at its deepest point. Salt water had entered from the coast, permanently changing the lake into a brackish environment. The disaster had not merely damaged the landscape, it had rewritten its geography and altered its ecosystem. There was one final, almost unbelievable scene. Days after being swallowed, 9 of the 11 barges rose back to the surface as pressures below the lake began to equalize. The drilling platform did not return. Investigators now faced the question that appears simple in almost every retelling of the disaster: who drilled in the wrong place? The answer was not simple at all. The Federal Mine Safety and Health Administration investigated the inundation in detail. The drill had almost certainly connected with the mine workings near one of their deeper levels. But the physical evidence needed to reconstruct the precise point of contact was now buried beneath a collapsed lake and a flooded mine. The disaster is often blamed on a specific coordinate conversion or mapping error. That explanation has been repeated for years, but the official investigation did not establish it as fact. Investigators could not conclusively determine whether the well had been drilled away from its intended position, whether the available mine maps failed to show the true extent of the underground workings, or whether several inaccuracies had combined. The companies involved disputed responsibility, and the lawsuits were ultimately resolved through settlements worth tens of millions of dollars. The mechanism of the catastrophe was clear. The precise mistake that placed the drill and the mine on the same path was not. That uncertainty may be the most important part of the story. Major engineering disasters are rarely caused by one dramatic decision made at the final moment. More often, they develop at the boundaries between systems, between two companies, two sets of plans, two surveys, or two assumptions about what lies beyond the visible edge of a project. At Lake Peigneur, the drilling crew understood its well. The miners understood their tunnels. But somewhere between those two underground pictures was a dangerous uncertainty. On the morning of November 20th, 1980, that uncertainty was only a small point on a map. Then the drill reached it. Today, Lake Peigneur looks peaceful again. Water covers the crater, vegetation has returned, and little on the surface reveals the scale of what happened below. But it is not the lake that existed before the accident. Beneath it lies a drowned industrial world, collapsed chambers, abandoned machinery, and a drilling platform that disappeared into the ground. The lake returned. The world underneath it did not.